All right, y'all. So 5.4 deals with what we call complex fractions. And y'all, a complex fraction is like a fraction that contains fractions in the numerator or denominator. So what we want to be able to do with these is simplify. So to simplify a complex fraction, that means to write it as a single fractions. So to simplify complex fractions, we want to be able to write as a single fraction. So we just want one thing in the top, one thing in the bottom. We don't want fractions in either the numerator or denominator, okay? All right, let me let one in real quick. All right, so I'm going to show you two methods on these. And the way I do these depends on how many fractions does it have in either the numerator or denominator. Okay, if I got more than one fraction, I'm going to multiply everybody by what we call the least common multiple to get rid of the fractions. If I just got single fractions in the numerator and denominator, then we'll work them a different way. So these will say simplify. So y'all, number one has 5 plus 4/5 all divided by 4 minus 5/9. So notice I got a fraction in the numerator and a fraction in that denominator. So my goal is to get rid of all these different fractions here and make this just a single number on top and a single number on the bottom. So the way we do that, we find the least common multiple of all the denominators. So let's see. For this one, I'm looking for the least common multiple between a 5 and a 9. Remember, we learned last week you can break your numbers down, and we had to represent all the factors. So y'all, I'm going to be quick on this. So the least common multiple between 5 and 9 would be 45. Now, I will say another quick way to find these least common multiples. If you take these numbers like 5 and 9, and you write out all the multiples of 5 and 45, I mean, of 5 and 9, you're looking for the smallest number they have in common. So like 5, we could do 5, 10, 15, 20, 25, 30. And then on 9, 18, 27, 36, 45. So notice at the moment, I don't have nothing in common. So let me keep going with these 5s. Let me do 35, 40, 45. Now notice the smallest number that you find with both of these numbers is 45, which we said was our least common multiple. So remember, multiples of a number are like that number times 1, times 2, times 3, and so on. And do that until you get a match, okay? So what you're going to do with this least common multiple, we're going to multiply all 4 parts of this fraction by 45. Remember, what you do to the top of a fraction, you got to do to the bottom of the fraction. And remember, so I'm going to come down and multiply 45 times all parts of this fraction. All right, at this point, we're going to start simplifying each part. So here, 45 times 5, you're just going to multiply that and get 225. Plus, right here, the reason we wanted the least common multiple, because that 45 will now divide by that 5. So if you divide 45 by 5, you get 9. And then we multiply the 9 times the 4 that's on top and get 36. All right, on the bottom here wasn't a fraction, so you multiply 45 times 4 and you get 180. And then that'll be minus. So y'all, now this least common multiple would divide by the 9. So 45 divided by 9 makes that a 5. And then that 5 times 5 gives you 25. So notice by multiplying by these least common multiples, the fractions were taken care of and they became single numbers. So now we just got to add the top, subtract the bottom, and see what we get. So our 225 plus 36 gives me 261 on top. 180 minus 25 gives me 155 on the bottom. At that point, you would try to simplify this final answer, but 261 and 155 does not reduce. So that would be our final answer. Now, I'm going to show you a way. Since this one has only numbers, I'm going to show you how to do this one on the calculator. Now, the trick on this one, on your calculator, you got to put the numerator and denominator in parentheses. So we would open parentheses and do 5 plus 4 divided by 5. Close the parentheses for the numerator. And then remember that fraction bar represents division. And then open up the parentheses for the bottom and have 4 minus 5 divided by 9. Close parentheses. When you do that, you're going to get a decimal. So to turn a decimal into a fraction, because remember, MathLab only wants our answers as a fraction, you would hit the math button and then enter twice. So y'all, let me show you that on a calculator real quick. So let me share that screen. All right, so remember, we got to have parentheses first, and then we had 5 plus 4 divided by 5. Close those parentheses, and then divide that by the denominator. Open your parentheses. 4 minus 5 divided by 9. Close parentheses, hit enter. Remember, we're going to get a decimal. So remember, to turn a decimal into our answer, we would hit math and then enter twice. And there's our 261 over 155. So y'all, they're not too bad. You just got to keep up with separating that numerator and denominator for the calculator. All right, number 2 has a 3/4 plus a 1/5 over 5/9 minus 1/3. All right, so 4, 5, 9, and 3 are the numbers I would look for my least common multiple of. So, doing it the quick way, I'm just going to come out, y'all, the least common multiple of 4, 5, 9, and 3 would be 180. So if you was writing out your numbers, you'd have to go quite a ways on that one, okay? But remember, you could do the prime factors, turn the 4 into a 2 times 2, 5's prime, 9 would be 3 times 3, and then that 3. Remember, all factors have to be represented, so you would have the 2 2's times 5 would be 20, The 2 3s would be 9, so that gives you 180. And you don't have to worry about this 3 because remember this one had 2 of them. So what we did last week would work on that and get that 180. So y'all, what I gotta do is multiply all 4 parts by the 180. So we'll do 180 times the 3/4 plus 180 times the 1/5 all over 180 times the 5/9 minus 180 times the 1/3. So we're going to start seeing what we get here. So y'all, let me see what I get when I 180 divided by 4 gives me 45. So 180 divided by 4 is 45. Then you multiply that 45 times 3, you get 135. Plus over here, 180 divided by 5, let's see what that gives us. That's going to give us 36. And then 36 times 1 is 36. All right, on the bottom, the 180 will divide by 9, making that a 20. And that 20 times 5 gives us a 100. And then that'll be minus, right here, the 180 divided by 3 gives me 60. And 60 times 1 gives us 60. So multiplying all 4 of these fractions by that least common multiple removed all these extra fractions, and we just got numbers on top and bottom. So let's add the top. 135 and 36 gives us 171 over 100 minus 60 gives us 40. And y'all, 171 and 40 do not reduce, so that would be our final answer. Now, on this one, remember, put the top in parentheses. So let's go do this one on the calculator real quick. So I'm going to put the top in parentheses and do 3 divided by 4. Plus, I had a 1/5, which would be 1 divided by 5. Close parentheses for that numerator, and then divide. Open parentheses for the denominator. I had 5 divided by 9 minus 1 divided by 3. All right, once I close my parentheses and hit enter, I got to turn my decimal back into a fraction by hitting math and enter twice. And there's our 171 over 40. So y'all, with numbers, you can do these either way. Sometimes numbers are tricky to get these least common multiples of. But y'all got that calculated there, okay? Now, number 3 is going to be with single fractions. And this one has variables. So I've got a x to the 3rd over y to the 6th over x to the 5th over y squared. So y'all, I do them a little different when I got single fractions. Notice I got a single fraction in the numerator and a single fraction in the denominator. That's different than over here where I had 2 fractions in each. When you got a single fraction, what we're going to do is we're going to take the top, x to the 3rd over y to the 6th. We're going to change from division to multiplication. And then we're going to flip the second fraction, just like y'all did last week. when we're doing those rational expressions. Remember, we always change from division into multiplication and flip the bottom fraction. So this will give me a y squared over x to the 5th. All right, so remember here, single variables can cancel each other. So the x's can reduce and the y's can reduce. So let's play with the x's first. You got an x to the 3rd on top and an x to the 5th. The x's are bigger in the bottom. So that means the x's will stay in the bottom. And then we're just going to subtract exponents. So take that 5 and subtract 3. 5 minus 3 gives me 2. That's going to leave me an x squared in the bottom. Now look at the y's. I got a y squared on top and a y6 on the bottom. The y's are bigger in the bottom, so they will stay in the denominator. And then we're just going to subtract exponents. 6 minus 2 leaves me 4. So that's going to leave me a y to the 4th in the denominator. Now, since both of these variables ended up in the denominator, that means in the numerator, we have to have a 1. So if all the variables end up in the denominator, y'all, you need a 1 on top. All right, y'all. So the next one's going to be single fractions again. I got 25 a squared minus b squared over ab. All of that over 5a minus b over b. Now, I know you got 2 parts up here, but notice this is one fraction here because it's got the one fraction bar. Okay, over here, you have to have 2 fraction bars for 2 fractions. This just has a lot more on top, but remember, this is one fraction divided by one fraction. So we're going to do what we did here. We're going to write the top, 25 a squared minus b squared over ab, change from division to multiplication, and then flip our bottom fraction so that we get a b on top and then a 5a minus b on the bottom. All right, so right off the bat, we can cancel the b. Because I got a b on top, that'll cancel with a b on the bottom. Remember, anything on top can cancel with anything on the bottom. Now, y'all, to go further, we got to factor this right here. That's the difference of perfect squares. And we know perfect squares are always factored into conjugate pairs. So the square root of 25 would be 5. So that's going to put a 5a in each parentheses. One will be positive, one will be negative. And then b squared puts a b and a b. All right, on the bottom is my a. Now remember, at the moment, since the b's gone, that's like a 1 over 5a minus my b. All right, you also notice here, this 5a minus b will cancel with this 5a minus b. So pretty much everything on the second fraction is canceled out. So all we have left for our final answer is the 5a plus b on top over the a on the bottom. So y'all, these are a little tricky. You just gotta remember, when you got these a squareds and b squareds, you gotta factor those things, okay? All right, so 5 will be like number 1 and 2, but it's going to have variables in it. I got 1 over y plus 6 over 1 over y minus 2. So notice this one has different parts on the top. I got fractions within this big fraction again. So since I got more than one part on top and bottom, on this one, I'm going to multiply by the least common multiple. And the only denominator we have is a y, and the most that happens in any of my fractions is 1 time. So my least common multiple will just be that y. Now, multiply all 4 parts of this by that y. So we'll have y times 1 over y plus y times our 6 over y times 1 over y minus our y times that 2. Remember, all 4 parts have to be multiplied by the y. But y'all look what happens. These y's cancel, making that a 1. And 1 times 1 gives me a 1. Right here, you don't have a fraction, so you're going to multiply y times 6, which will give us 6y. On the bottom, these y's cancel, making a 1. 1 times 1 is 1. Minus y times 2 gives me a 2y. So now I just got the single denominator, single numerator here, single denominator. They got 2 parts, but notice there's not other fractions inside that. So this would be our final answer. So the trick is to turning it from having small fractions inside the overall fraction into just having one big fraction, okay? So y'all, one more of these and then we'll move into something else. So these are sort of tricky, and I will say, I think we only do this like once in the whole college algebra, and it's just in one section where you have to do one problem doing this. We're not going to kill you in college algebra with this stuff, okay? All right, y'all. P minus 1 over P all divided by P plus 1 over P. So really similar to this one. So since I got 2 parts in top, 2 parts in the bottom, I'm going to solve this one by finding my least common multiple. And y'all, the only thing in the denominator is a single P on either fraction. So my least common multiple will be that P. But y'all now multiply that P times all 4 parts. So we'll have P times P minus the P times 1 over P. All that over P times that P plus our P times the 1 over P. All right, so let's see what happens. Nothing cancels here, so P times P is a P squared. Minus, well, y'all look here. The P's cancel, making a 1. And 1 times 1 gives me a 1 on top. Now we work on the bottom. P times P, nothing cancels, so that's going to give you a P squared. Plus, right here, the P's do cancel, giving me a 1. And 1 times 1 is 1. Now, y'all, I would go further, but the bottom of this doesn't factor since it's being added. Now, the top would be perfect squares, but I'm not going to worry about factoring that because there's no way you can factor the bottom. And since these don't have the same signs, this here would be our final answer. So, y'all, there's only 6 of them problems. And we're not going to kill you with this. This is just... All right. All right, I'll fix that. All righty, y'all. So we won't kill you with those in college algebra for sure. We just wanted you to be exposed to them for maybe one problem in that class, okay? All righty, so this next section is 5.5 and 5.7. And this is solving rational equations. So equations containing fractions. So I'm going to write my steps out first. And then we will start working these problems. So y'all, the first thing you want to do, you want to find the least common multiple of all denominators. Because that's the first thing we're going to do to these. We're going to find that least common multiple so that we can eliminate these fractions. So once we find the least common multiple, we're going to multiply each term by the LCM. Even if it is not a fraction, we got to multiply every term by that LCM, okay? All right, once we've multiplied each term by the LCM, we're going to simplify each term. And y'all, once I've simplified each term, I'll have no more fractions left. So then we solve for the variable. Now remember one thing here. If we have any x squared terms, we have to solve those by factoring. Now, if I don't have any x squared terms, I'm just going to get my variable on one side, my numbers on the other, and be done. But if I do have any x squared terms, we have to solve them by factoring. And y'all, the last thing you do, if needed, you check it if needed. Okay, so the trick on these fractions is to get rid of the fractions by using our LCM. But you know, that's the same thing, remember, as the least common denominator, okay? So these examples, all they're going to do is say solve. And then check if needed, okay? So this first one is just going to be numbers. Now remember, numbers we could do on the calculator if we want to. So I got a 4/5 plus 2 over 27 is going to equal a y over 45. All righty, so the first thing I got to do is find the least common multiple of these numbers. So if you did it on a calculator, remember I showed you how to find the least common multiple on the calculator. If you did 27 and 45, your least common multiple would be 135. But what we're going to do now is multiply all three parts by 135. Now, the reason I did that, because now I can cancel these denominators out. So let's see what we get. 135 divided by 5 gives me 27. Because this way you're finding the least common multiple because it'll divide by all of these denominators, okay? So now 27 times 4 gives me 108. But guess what? That fraction's gone now. So now the second part, I got 135 divided by 27. That's going to give you 5. And then 5 times 2 gives me 10. That's going to equal the right side. So let's see what we get. 135 divided by 45 gives me 3. And then 3 times y gives me 3y. So notice, we found the least common multiple. We multiplied each term by that least common multiple. And we simplified each of these terms. We now have no fractions. So we're going to solve this for the variable. So the first thing we're going to do, we're going to add like terms on the left side. So 108 plus 10 gives us 118 equal to the 3y. All right, y'all, then our last step, divide both sides by the 3. So we have 118 divided by 3 equals 3y divided by 3. So the right side, the 3's cancel, we get our y. So y'all, let's see if we can reduce that 118 over 3. So I'm gonna go to the calculator. And I'm just gonna do 118 divided by 3. That's going to give me a decimal, but I'm going to turn the decimal back into a fraction by hitting math and enter twice. And notice I still get 118 over 3, so that means that that fraction does not reduce. So 118 over 3 would be our final answer. So the trick on these is just sort of play with them and see if these final answers were reduced or not. All right, y'all, number 2. X over 4 minus x over 5 is going to equal 13. All right, so let's find our least common multiple. So the only denominators I have are a 4 and a 5. So the smallest number that 4 and 5 both go into would be a 20. So multiply all 3 of these by the least common multiple of 20. Now, when you got small numbers like this, you can just multiply them to get that least common multiple. So let's multiply everybody by 20. So watch this. The 20 divides by the 4, making that a 5. So I got 5 times x, which is 5x, minus this 20 divides by 5, making a 4. And 4 times x is 4x. Now, y'all, the right side, nothing reduces. So we multiply that 20 times 13. That gives us 260. All right, so let's see. All we got to do on this one is combine like terms on the left side. So 5x's minus 4x's leaves me 1x equal to my 260. So y'all, let's check this one and see if we get a 13 out of it. So I'm just going to show you how to check one of these. So to check it, you would put that 260 in for these x's. So I got 260 divided by 4 minus 260 divided by 5. That has to equal 13. All right, y'all, let's see. 260 divided by 4 gives me 65. Minus 260 divided by 5 gives me 52. That has to equal 13. And y'all guess what? 65 minus 52 gives me 13 equal to 13. So our answer checks out. So notice if you want to check them, plug your answers back in for those x's. All right, y'all, moving on. Let me get this back up here. All right, so our number 3 here. We got a y plus 12 over y is going to equal a negative 13. So y'all, if you notice, this one only has one denominator that we're worried about, and it's that y. So our least common multiple will be that 1y. But multiply all 3 parts by that y. So you're going to have the y times the y plus the y times the 12 over y is going to equal to y times that negative 13. All right, so right here, nothing cancels. So y times y gives you a y squared. Plus, now the middle, the y's do cancel, making a 1. And 1 times 12 is a 12. And over here, nothing cancels. So negative 13 times y gives us a negative 13y. Now, this one is quadratic because it's got an x squared term. Although it's a y squared, it's still a squared term. So remember, to solve these kind of equations, we need a 0 over here. So to get a 0 on this side, I'm going to add 13y to both sides. Well, that's why you had to learn how to factor, was to learn how to solve these kind of equations, okay? Now I'm just putting it in order. That's why I threw the 13y sort of in the middle, because I'm going to bring down my y squared. Then bring down that 13y. Then bring down my 12, and all of this is now equal to 0. So remember, before you factor, you got to have a 0 on that side. Now, we're going to factor this to get our 2 answers. Remember, there'll be 2 answers because we got that y squared. So we'll have a y and a y. Remember, if the last number is positive, both of these factors will have the same sign as the middle. So both of these will be positive. And then I want factors of 12 that'll add to get 13. That'll be what, 12 and 1? So remember, they add to get the middle, they multiply to get that last number. All right, so it's factored. Now set both of these factors equal to 0. So I'll have y plus 12 equals 0 and y plus 1 equals 0. In solving both of these, I'm going to add minus 12 on the first one. So I get y as a negative 12. On the second one, I'll subtract 1 and get y as a negative 1. So for this one, I got 2 answers. I got negative 12, comma, negative 1. Now, there ain't many of these where you had to factor them, but definitely number 3 is one of them, okay? All right, y'all ready for number 4 here? We got 8 over x plus 7 over x equals 5. All right, so there's 1x in this denominator, 1x in that denominator. So the most that happens is 1 time in each fraction. So that means all I need for my least common multiple is 1x. That'll be enough to cancel all my fractions, okay? So we got our x. We're going to multiply all 3 parts by that x. So we'll have x times 8 over x plus x times 7 over x will equal to x times our 5. All right, y'all look. X is canceled, giving me a 1, and 1 times 8 is an 8. The second one, the x is canceled, make it a 1, and 1 times 7 is a 7. On the right side, nothing's canceling because we don't have a fraction. So x times 5 is just 5x. All right, look over here. We got like terms. So we're going to add the like terms over here. And notice I don't have an x squared. I have an x. So I don't have to do all this zero stuff. All I got to do is solve this for the x, okay? So when we add the like terms, we get 15 equals 5x. Now remember, I want that to be a 1x. So I'm going to divide both sides by that 5. So 15 divided by 5 will give me a 3. And over here, the 5's cancel, making that a 1x. So the final answer on that, 3. So if we put a 3 here and a 3 here and added all this up, we would get a 5 for that, okay? Oh, so y'all, let me show you a trick. Now notice, these had 3 parts to them. This one had 3 parts to them. So to solve them, I found my least common multiple. Now, we got something else we can do when we just have 1 fraction equal to 1 fraction. So y'all watch this. If we have something like a over b equal to c over d, if we just have 1 fraction equal to 1 fraction, then we can cross multiply this and get an AD on one side equal to the B times C on the other side. We can get rid of these fractions by cross multiplying. So I did the A times D and then the B times C. So this would have been the part of in life where you learned about what we call cross multiplying. And by doing that, you're getting rid of them fractions pretty quick. So watch this. Number 5, I got y minus 7 over y plus 2. That's going to equal 2/3. Notice I got 1 fraction over here because I got 1 fraction bar equal to 1 fraction. So since I got this pattern right here, we're going to solve this by cross multiplying. So we're going to cross multiply. So this y minus 7 will multiply by that 3. So that's going to be 3 times y minus 7. Then we do the denominator times that 2. So that's going to give me 2 times y plus 2. Right, numerator of 1 times the denominator of the second fraction, and then its denominator times the numerator of the other fraction. Now, to get rid of parentheses, we're going to distribute the 3. So 3 times y is 3y. Minus 3 times 7 is 21. That's going to equal our other side. 2 times y is 2y plus 2 times 2 gives us 4. Now, what's nice on this, when you do the cross multiplying, you don't got to find all this least common multiple stuff. Now, you could do the least common multiple to this, but that would be a lot of extra work, okay? So what we want to do first is get the y's all on one side. So to get the y's on one side, we're going to subtract 2y from both sides. So 3 minus 2 leaves you 1y minus 21. These y's cancel. So what is left is that 4. All right, so now we want the y to be by itself. So since this 21 is being subtracted, we're going to come in and add 21 to both sides. So that brings down my y. The 21's cancel. And on the other side, 4 plus 21 gives us 25. So if you put that 25 in for these y's, simplify this, it would equal that 2/3. So y'all, I really like the cross multiplying stuff a lot better than I do the least common multiple. So y'all, let's see 6 here. Z plus 4 over Z equals a 7 over 6. So once again, one fraction equal to one fraction. So we're going to cross multiply again. So this Z plus 4 multiplies by the 6. So that's going to give me 6 times Z plus 4. That's going to equal this Z times that 7, which will just be what, a 7Z. All right, so to solve this, we got to get rid of our parentheses. So 6 times Z is a 6Z plus 6 times 4 is 24. All that's going to equal 7Z. Now, I'm going to tell you the truth on this one. We can be done in one move if we move the Z's all to the right side. Because if I got a Z and a number equal to a Z, I'm going to try to get this Z to that side. So to do that, we're going to subtract our 6Z from both sides. So these Z's cancel. All that's left is 24. And that's going to equal the right side. Well, y'all look at that. 7 minus 6 leaves me 1Z. So if you put that 24 in, 24 plus 4 would be 28 over 24. 28 over 24 will reduce to a 7 over 6. So these will check out. You just got to plug back into those, okay? So one more doing the cross multiplying. So let's see, that was 6. So this will be 7. All right, so for our 7, we got 8 over 5y minus 2. That's going to equal 4 over 9y. All right, so remember, I'm going to do my cross multiplying. So this 8 multiplies by the 9y. So 8 times 9y on one side. That's going to equal this 5y minus 2 times that 4. So that'll be 4 times 5y minus 2. All right, also, let's see what we get. 8 times 9 gives me 72y. Over here, 4 times 5y gives me 20y. Minus 4 times 2 is 8. All righty, let's see. We want all the y's over here because over here's a y and a number. So to get this number by itself, I'm going to move all the y's over here. So we're going to subtract 20y from both sides. All right, y'all. So 72 minus 20 gives me what? 52y equal, those y's cancel. So all that's left is our -8. All right, so we want the 52y to be 1y, so divide both sides by 52. So the 52's cancel, making that a 1y. Y'all, these will simplify because they're both definitely even numbers. Actually, I think they'll both divide by 4. But you watch this. So we got a -8 over 52. Let's reduce that on the calculator. So we'll do -8 divided by 52. That's going to give me a -0.153. But remember, I want that to be a fraction. So I'm going to hit math and enter twice. And I get a -2 over 13. So yeah, it looks like they divided the 4s out of top and bottom on that. Now y'all check this one out. This one says solve v divided by z equals a over d for the v. Now these are capital V and Z, and these are small letters. In Math Lab, capital letters have to be capitalized and the small letters have to be small, okay? If you put a capital A here or a capital D for that, it will mark those wrong. So let me write my problem. Capital V over capital Z equals a small a over a small d. So I'm solving this for the V. But remember, I got a fraction equal to a fraction. So I'm going to cross multiply this. So I'll do the V times D on one side. That's going to equal this Z times that A. Now remember, I'm solving this for the V. Since this V is being multiplied by the D, we're going to divide both sides by that D. So capital V, little d, divided by the little d will equal to capital Z, little a, divided by the little d. See, y'all look here. These d's cancel, giving me my V. Over here, we cannot do anything else to that. So that's going to stay a Z times a little a, all divided by a little d. So basically all we did, the Z that was on the bottom on this side went to the top on the other side and we were done. Okay. All right, this one we're going to solve P equals 719.2x over capital H squared. We're solving that for the H squared. Now, to make this side look like a fraction, if you want to, put a 1 under that. And I'm going to cross multiply again. So remember, this p times the h squared. So I'm going to have a p h squared on one side. That's going to equal this 1 times that 719.2x. Well, 1 times 719.2x is 719.2x. So we're solving it for the h squared. Since the h squared is being multiplied by the p, we're going to divide both sides by that p. So the ph squared divided by p will equal the 719.2x divided by the p. So y'all look, these p's cancel, giving me a 1. So that's just 1h squared, which is h squared. Over here, we can't do nothing to that to simplify it. So that's going to stay 719.2x all over RP. So basically on this one, all I did was put the h squared here and the p down there. Sort of like I just flip-flopped them, okay? Oh, look, y'all, that was all of those. So remember, if you got a single fraction equal to a single fraction, cross multiply that. If we had like earlier when I had 3 parts, we found the least common multiple to get rid of them fractions, okay? Now we do a lot of these in college algebra where you got to cross multiply. So y'all, let me just say, this is just going to be a preview of what's coming up next week. Thursday, we're going to review for this 4th test over to chapter 5 stuff. And that's all we're going to do Thursday is review for that test. But y'all, wanted to give you a preview of what's coming up. We're going to start messing with these square root radicals, and we'll mess with stuff like cube root radicals, okay? So that's what's going to be coming up for the chapter 6 stuff, where you do square roots and cube roots and all that fun stuff. So we'll get out of the factoring stuff and we'll start doing stuff that's a little bit easier, I think, okay? Alrighty, also, let me go back to our main screen. So y'all, basically not a lot of work before we review. But some of these questions were tricky, remember, so all you're doing tonight is the pi 4 and then the equation stuff. So any questions?